Hi, everyone. So in statistics, we ask questions, we collect data, we analyze that data, and then we draw conclusions. The questions that we ask are questions about a population. And a population is the collection of all the individuals for which we're asking that question. And when I say individuals, I don't only mean people, and I know my pictures show people here, but individuals can be really anything. So I could be asking about all of the cars bought in the last year in the United States, right? And all of those cars would be the individuals, or the population. Or I could say, ask a question about the trees in Maryland, and those would be then the individuals within the population. So at the beginning of Chapter 1, we talk a lot about how to sample the population. Because when we ask questions about the population, we can't normally then collect data from the entire population. It's usually much too large and much too difficult to do so. So instead, we want to collect a subset of that population. And the challenge is to have that sample, that subset, be perfectly representative of the population and without any bias, so that when we make conclusions about that sample, we can then apply it to the population. So there's a lot of discussion about how do we collect a sample that's representative of the population. And one thing that is really important is that whatever sampling method we choose, that it applies randomness in some way. And that's because the randomness will account for all of the characteristics within the population that we know and that we don't know. So like, for example, some people will just say, well, if you have this population, why can't you identify all the characteristics and then just pick individuals that will perfectly represent that population? And the reply to that is because there's a lot of times when you don't know all of the characteristics of your population, and there could be underlying characteristics that you have not identified. Randomness accounts for all of this. So having randomness involved in how you choose a sample will then reduce bias and will make it more likely that you have a representative sample, or a sample that's representative of your population. The other thing to keep in mind is that when you have a sample and you collect data and you calculate statistics on that sample, you're always going to have sampling variability. And this is kind of getting ahead of us a little bit, but I want to put it out there right away in the beginning of the semester. So what do I mean by sampling variability? So you could have the perfect sample, and you could collect data on that sample and calculate statistics and make a conclusion, and you could be slightly off from the population, and that would be normal. It would be perfectly normal, and it's due to randomness. So, and you're kind of already familiar with this. You probably just don't know it yet. So imagine that you have a coin and you flip it 10 times. Are you always going to get 5 heads and 5 tails? No. Sometimes you're going to get 7 heads and 3 tails, or 6 heads and 4 tails. That doesn't mean that there's anything wrong with the coin. That doesn't mean there's anything wrong with the way you flipped it. That is just natural variability. So you could have 10 perfect samples that are perfectly representative of the population, and you could calculate statistics on those samples, and they might be slightly different. And they might be then also slightly different from the overall population. And it doesn't mean that there's anything wrong. It just means that we have this natural sampling variability. We're going to talk a lot about this at the end of Unit 2 and Unit 3. But I just want to put it out there right in the beginning when we talk about samples. So we're going to talk about several sampling methods, some of which apply randomness and others that will have some inherent bias. So, four main sampling methods that involve randomization. The first one is called a simple random sample, or we abbreviate it with SRS. This is just a lottery method, something like pulling a name out of a hat. That would be a simple random sample. Or if you say you have a really large population, you could assign a number to every individual within the population and then randomly use a random number generator to randomly choose 50 numbers. That's a simple random sample. Then we have a systematic sample. This is where you would create a list and you'd randomly choose a starting spot. So maybe you roll a die and you get 5. So you're like, okay, I'm going to start at individual number 5. And then after that, you have some kind of system, like you pick every 10th individual after that until you get to a certain size. That would be an example of a systematic sampling method. Then we have two more sampling methods that involve grouping. It's clustered and stratified, and it's really easy to get these mixed up. So as you're reading in your textbook, make sure that you really look at the examples for these and understand the differences. So clustered would be if we had using naturally occurring representative groups. And then we randomly choose one or more groups and sample everyone or every individual within those groups. So for example, say we want to understand elementary school children in Maryland. Well, representative groups would be elementary schools. So, and they're kind of naturally occurring representative groups. Are they perfectly representative? No, but they're pretty good. And so we would randomly choose one or more elementary schools, and then we would sample every individual within those elementary schools that we randomly chose. Stratified is slightly different. They're still grouping, but instead of having representative groups, you have homogeneous groups. So again, let's go back to elementary school children. Maybe instead of looking at elementary schools, we just look at a big list of kindergartners, first graders, second graders, and so on. And for a stratified sampling method, then we would randomly sample a certain number of individuals within each group. So it's just kind of the order of the randomization. So clustered representative groups, randomly choose the groups, sample everyone within the randomly chosen groups. Stratified, homogeneous groups, randomly sample certain individuals within each group. There's a couple of other sampling methods, and census is kind of over on the side here. Census means that we sample the entire population. And your textbook actually doesn't talk about census as a sampling option. But if your population's really small, like say I just want to understand all the students in my classes this semester, I could just send a survey to all my students in my classes this semester. My population's pretty small, and so I could do a census. A census is not biased, but it also doesn't involve any randomization. It's just the entire population. And if that's possible, that's great. But we do have two other types of sampling methods that are inherently biased. The first one is called a voluntary response sampling method. And it's pretty common. It's where researchers just put a survey out there, out there on the web. And anybody who's interested should log on and fill out the survey. So instead of the researchers choosing who will be involved in the survey, it's like they're just letting they're letting the individuals choose whether or not they want to be involved. And I don't want to be confusing here because everyone has the choice on whether or not they want to be involved in a sample, right? Just because I say I'm going to sample all of my students in my classes doesn't mean that everybody's going to respond to my survey. And that's their choice. And we'll talk about what type of bias that creates, even if I have a great sampling method. But with the voluntary response sampling method, the researchers aren't even trying to create a representative sample. They're just throwing it out there for anybody to fill in. And what happens is that people with really strong opinions are the only ones that respond to those kind of surveys. So there's a lot of bias involved in that. The second type of bias sampling method is a convenience sampling method. So it's basically that we sample individuals that are convenient to us. So I want to understand the trees in Maryland, so I go out my backyard and I just look at the trees in my backyard. Right? That would be a convenience sampling method, and it's not going to be representative of all the trees in Maryland. Your textbook talks about times when a convenience sampling method is kind of the only option. So I think one of the examples they use is if a company has huge concrete bricks and is trying to sample those bricks, and they're on these gigantic pallets, well, you're going to only sample the bricks on top. You're not going to dig down to the bottom. So sometimes a convenience sampling method is the only option, but you have to understand that there's going to be a lot of bias involved in that. And then finally, just one more note about sampling when you get into reading this is that when we talk about notation for measurements that we take from a population versus a sample, and this is going to, again, we're going to look at this when we get further into chapters 2 and 3 and 4. But when we're talking about a population and we calculate something like a mean or a standard deviation, we call those parameters, and we use Greek letters to represent them. So if you see something like mu equals, you know that they're talking about the mean of the population. Whereas with a sample, we calculate statistics, not parameters. So we calculate statistics on a sample, and so the mean, the standard deviation, the proportion would be called a statistic. And we use things like X bar to be the mean, and S to be the standard deviation, and P to be the proportion. But again, we will review that much more in future chapters, but there is a different notation depending on if you're talking about a population or a sample.